Good day, future engineers. We're now on our fifth example now for our topic on application of definite integral, determination of the volumes formed by the revolution of the areas bounded between curves. Okay, so for this one, we have a manufacturing drilling a hole through the center of a metal sphere of radius. We have a radius here of 5 inches. So take note now, there is already a unit. We have our inches as shown in the figure. The hole has a radius of 3 inches. What is the volume of the metal ring? So we have a sphere. Its radius is 5 inches. And then a hole is drilled in its center with a radius of 3 inches. Now, what is the volume of this of the metal ring that is formed here? So as you can see here, we are going to use we can use the Washer method. The volume is just equal to pi times the integral of. So the strip here is a vertical strip, therefore our lower and upper limits is along the x-axis, and then this is revolved along the x-axis. That is just the outer radius, square of the outer radius minus square of the inner radius, dx. So anong dx gani since we were using the vertical strip. We have here the x as its width, and we also have the y as its height for the radius. And then what is our lower limit? We have here the 4, any 4, -4 and +4. So our lower limit is -4, upper limit is 4. So we just write that one, v is equal to pi times the outer integral of the outer radius. Our outer radius is represented by what formula? The square root of 25 minus x squared. Amo ni siya nakuha. Ingon niya, we have a metal sphere with a radius of 5 inches. So, kung circular na siya, that is just equal to x squared plus y squared is equal to r squared, di ba? Or x squared plus y squared is equal to 5 squared. That is for circles with their vertex located at the origin, at 0, 0. So following that formula, we were able to derive actually the lower and also the upper limit. So from this one, we can solve that our y is just equal to 20 square root of 25 minus x squared. So our outer radius represented by this curve is just equal to square root of 25 minus x squared minus, how about our inner radius? Our inner radius is just 3 squared. The x lower limit is -4, upper limit is +4. Okay, just simplify this one. You'll have pi times integral of, you have a 25 minus x squared minus 9 from -4 to +4 dx, which is equal to pi integral of, we have a 25 minus 9 that will become our 16 minus x squared dx from -4 to 4. Then we will arrive at pi times 16x minus 1/3 x cubed to be evaluated from -4 to +4. Now from that one, we will arrive that the volume of this metal ring is just equal to, we will have the 256/3 pi cubic inches. So na siya unit. because a unit is given. Hindi siya cubic units but cubic inches. Okay, let's proceed to our next example. Find the volume result of revolution formed by revolving the region. So we have here a region bounded by y is equal to x minus x cubed and the x-axis. About the y-axis. So revolve daw siya along the y-axis. Now if you look with this one, someone, actually we cannot apply the disk method, no, with this one because the revolution is along the y-axis. So here, we're going to apply now the shell method or the cylindrical method. Okay, ato lang dumdum mo, no? The volume. Since the shell here is revolving along the y, that is just equal to 2 pi integral of the radius along the x or p of x times h of x dx from a to b. So from the y, from the axis of revolution, paingon sa average radius na to sa itong differential element, that is just equal to x. Anong x? Why x? Is it given? So the radius there is just x because that moves from 0 to 1. And then that is just our x. It means that it changes as the x increases or also decreases. So we will have 2 pi times integral of x. That is our p of x, the average radius times. How about the h of x? H of x or the height is just the height of this curve at each x as represented by that curve. So that is just the h of x is just the y is equal to x minus x cubed dx. How about our lower and upper limits? Already shown here that our lower and upper limit is just the 0 to 1. So we'll have a 2 pi integral of, we just distribute x, so we have x squared minus x to the fourth from 0 to 1 dx. This is just equal to 2 pi times integral of 1/3 x cubed minus 1/5 x to the fifth dx from 0 to 1. Or simply 2 pi, no. Then siya, sorry, this is not integral. That's rather, this will be evaluated from 0 to 1. Of course, if we have a 0 that is just equal to 0, then we'll have 2 pi times 1/3 minus 1/5, or simply the volume of the solid of revolution form here is just equal to 4 pi over 15 cubic units. Now, let's say, sinem, someone might ask of, if we can use the washer method here. So let's say we're going to apply the washer method, no, with this problem. So what will happen? Like this one. Para makuha na to si volume. Diba, washer method is just equal to the pi times integral of square of the outer radius minus square of the inner radius. Now, since it revolves along the y, so that is dy from C to D. So we'll have pi times the integral of what is our outer radius. Our outer radius is represented by this curve, diba? That is just equal to square of x minus x cubed squared minus what is our inner radius at this point. The inner radius is also represented by the same curve that is equal to x minus x cubed squared. So may tabo that will equate to 0. So we cannot apply the washer method all at once with this problem. Actually, we can apply the washer method with this problem, but so may buhaton nato, we need to divide this curve aron dili siya mo equal to 0. So saan na to pag-divide? We will get its upper point, the maximum point. Aron we will have a two volume. We just equate these two volume of the washer here using the washer method. That is the first volume, and the second volume. So if that's the case, you just need to find the location here. That is the inner radius. What is that one? And then our outer radius is just the x minus x cubed. No, that is not x minus x cubed, but rather we need to find that as an x, and then we need to isolate the x and the y. So mo na siya mahitabo no. That is already quite complicated. So for this specific problem, it is much simpler to use the shell method or the cylindrical method. Okay, about for the item number 7, find the volume of the solid after revolution by revolving the region by the graph of x is equal to a to the negative y squared, and the y-axis where y is equal to or greater than to 0 but less than or equal to 1 above the x-axis. So the our axis of revolution is along the x-axis. Then we're asked to find the volume formed by rotating this one, the region bounded by the graph. So that is just equal to, since that is a horizontal axis for the kuan, for the shell method, of course, opposite na siya kung horizontal axis ang ato ang axis of revolution, then along y side ang ato ang i-consider na values. Then we need the p of y, h of y, dy from c to d. Our lower and upper limit is already shown in the graph, that is 0 to 1. So we have 2 pi times the integral of our p of y, or the radius, is just y at any y from 0 to 1. So we use only the y. Our h of y is just the e to the negative y squared dy from 0 to 1. Now if we let our u is equal to negative y squared, then our du is just equal to negative 2y dy. So we'll have 2 pi as the integral of, we'll have negative 1 half times 2 negative 2y e to the negative y squared dy from 0 to 1. Then we'll have negative pi integral of, we'll have e to the u du from 0 to 1, v is equal to negative pi e to the u, and so we evaluated from 0 to 1. That is equal to negative pi e to the negative y squared to be evaluated from 0 to 1. Now, if we evaluate this specific answer, then we'll arrive at the volume created by this, or the solid formed by the revolution along the y-axis, is just equal to, or not really equal to, but approximately equal to 1.986 cubic units. Okay, down to our last problem. Just to find the what? The volume of the solid formed by revolving the region bounded by the graph y is equal to x squared plus 1, y is equal to x is y is equal to 0, x is equal to 0, and x is equal to 1. So it's already shown here, no? Actually, this is the same problem from our previous example. Let's try to solve first here. No? The the axis of revolution is the y-axis. So therefore, our atong volume is 2 pi integral of t of x, h of x, dx from a to b. Our lower limit is 0, upper limit is just equal to 1. 0 and 1. What is our p of x, or the average radius? The average radius from the axis to here, that is just equal to x. So we'll have 2 pi times the integral of x times. How about what is our h of x? Our h of x is just its height that varies as we go through this curve, and this curve is a function of x, which is equal to x squared plus 1. So we write just the x squared plus 1, the x from 0 to 1. Okay, simplify, we'll have 2 pi times integral of x cubed plus x dx from 0 to 1, 2 pi times 1/4 x to the fourth plus 1/2 x squared to evaluate it from 0 to 1. And finally, we'll arrive at our answer that the volume of this solid of revolution is just equal to 3 pi over 2. Actually, this problem has a similar problem to already discussed earlier. This one. No, this is a similar problem, but on this specific problem, we did not apply the shell method. We apply the washer and the disk method. So that's why we have a separate solution for the washer method and then the disk method, and then we combine this both solution and we arrive at our answer as at 3 halves pi, or 3 pi over 2 cubic units. Now, by the application of the using the shell method, our solution is just very short, and then it's much simpler to solve. So, diba? So here you can see that there are problems in the solid of revolution where we can use more than one method. We can use the this method, we can also use the washer method, or we can also use the shell method, or we can use the this and the shell, or the washer and the shell. But the thing is, you just choose which one is much easier, much simpler, and one which will yield a faster result. Okay. So that is just the basic concept of the application of the definite integral in the determination of the volume of the solid form by revolving the areas bounded by the curve along an axis of revolution. So wala to dyan, just don't forget the concept. Uh, just graph and then find the limits. Determine what the strip that you're gonna use, your differential, or determine what differential element or a strip that you're gonna use. Determine the lower and the upper limits. Diba? Understand. Remember that this method is just very simple, that because that is just pi r squared h. The shell method is also quite simple because that is just 2 pi times the average radius times the length times the thickness. Say that is a dx or a dy. So, okay, so that's all for our application for a definite integral in finding the volumes formed by the solid of